Okay, angle relationships. There is a lot of different rules you need to remember. Things like right angles equal 90 degrees, straight angles equal 180 degrees, angles at a point equal 360, vertically opposite angles are equal, angle sum of a triangle is 180, angle sum of a quadrilateral is 360. Good, this is good. All right, then we have the three parallel lines rules, which are corresponding, co-interior, and alternate. Okay, so a lot of those kind of names should be on your study sheet to help you remember them. And if you can fit it in, maybe an example of each one. So going through question 1, B and C are something angles. So B is here, and C, this one next to it. What do you think the missing word is? What kind of angle are they making? 180 degrees, which we would either call a straight angle, which would probably be the one I would expect you to put in there. They are making a straight angle. The word that I think they're wanting to go in there, which would probably fit the sentence a little bit better, is the word supplementary. That was a special word that we had for two angles that add to 180 degrees. Okay, what about B and D? What are they doing? They are vertically opposite. So they've got the two straight lines and they are directly across from each other. So they are vertically opposite angles. D and E are in a right angle. That's right. So you can either put right angle, or what is the other bit more fancy name for that? No, that was for the straight line. Starts with C. Complementary. Good. A, B, C, D, and E form a, so that's all of the angles going all the way around. They form a revolution. A revolution is not really a reason that we would normally give. If we had that in a question, we'd call it angles at a point, but that doesn't fit the sentence. So we're just going to call it a revolution for that one, okay? Okay, in question 2, these are the ones where you have to find a missing angle, and the key thing is there written in red, you must give reasons. So I'm just going to do a couple. Question B is one of them. There are 2 letters in there, A and B, that I need to find. Usually alphabetical order is the best way to go, so I'm going to start with A. A is in the right angle with the 65, right? So we are going to make an equation where we go A plus 65 equals 90 degrees. And then we write our reason in brackets. Right angle equals 90. Then we do our opposites to solve that. I'm going to go minus 65 to get rid of that. And A equals 90 minus 65 is 25. Okay, so I had to write that a little bit above because now I still have to do B. To find B, what do you think the reason is I'm going to use? I have both of those 2 angles together are making a right angle, and I'm trying to find the angle going around the other side. 180 is a straight line, it's not making a straight line. 360, which is called angles at a point. Okay, so I'm going to add together the B with the 90 degrees. You could have done it separately. You could have gone B plus 25 plus 65, but just doing 90 makes it easier. Is equal to 360 degrees because of angles at a point. Okay, then we do the opposite. So minus 90 minus 90. B is equal to 270 degrees. Okay, so anytime I'm marking a question like that, I'm looking for both your answer with some working and your reason should be there in the brackets. Okay, on to next page. On the diagram, label the following. So I'm going to do the first one. I want to put on there the angle that is corresponding between the A, and I want to put on a letter B. Corresponding, we had shapes to help us remember. Do you remember the shape of corresponding? That's cointerior. F, good. So if I have A, if I draw around the A, to make an F shape, I would need to come up here. It'd be an upside down F, and that angle in there would be the angle B that I'm trying to make to do the corresponding shape. The other way of thinking of it is that corresponding needs to be on the same side of the parallel lines and on the same side of the transversal. Okay, so I've just done that first one. You'll now then need to do B, where you're doing an alternate angle. Where would that go? And you'd mark that with a C. But I'll leave that one for you. Question 4. Parallel lines, and in this one, I'm doing A, B, and C. There are 3 letters in there. So starting with A, what could I use to work out A? What shape are they making? Cointerior, good. So that means the cointerior is the biggest one, the one that needs some working out because they add to 180 degrees. So I will do A plus 72 equals 180 because cointerior angles equal 180. Minus the 72, and I get A equals 108. Okay, moving on to B. Remember that you could do different reasons here. Often when there's multiple steps, there's different ways to get the answer. Could anyone give me one option to find B? No? Yes. That's the one I was after. Very good. The B is making the Z shape with the 72, so that's alternate. So you could say B equals 72 because alternate angles are equal. The other option you could have had is you could have done a straight line from the A that you just found. There would have been a little bit more working out, but that's okay. You'd still get the same result. Okay, what about C? Again, you've got a few options here. Vertically opposite's the easiest one. Yes, good. So C is going to be equal to 72 because it's vertically opposite the A, right? So it's going to be the same as the A. Oh, no, not 72. It's going to be 108. 108 because it's the same as an A. The one that's across from. And the reason is vert op angles are equal. Yeah? Okay. Let's keep moving, see what else we can find. Triangles, question 5. So you should be able to look at a triangle and classify by its sides and by its angles. The side names are, up the top line there, scalene, isosceles, and equilateral. Scalene means no sides the same length. Isosceles, 2 sides the same length, and equilateral is 3 sides the same length. So for A, which one would it be? Isosceles, good. It doesn't actually have the markings on there for the sides, but because the angles are the same, that means those sides must be the same. Okay, now we want to name it according to the angle. The acute, it means all the angles are less than 90. A right angle means I have a right angle, one right angle in it, and obtuse means you have one angle that's bigger than 90. What do I have? Obtuse. All right, and so you can do the other 2. Then in question 6, we want to find values of missing angles in triangles. And remember, the angle sum of a triangle is always 180 degrees. I'm choosing one of the harder ones because it's an isosceles in there as well. So because of the isosceles sides in that triangle, the 81 at the bottom here, this one here will also be 81 because the base angles have to be the same of that isosceles triangle. Then, to find A, I'm going to make an equation. A plus 81 plus the other 81 equals 180 because of angle sum of a triangle equals 180. Before you do your opposites, add together the two numbers on the left-hand side. So 81 plus 81 is 162. And then I can subtract 162 and get my answer, which is 18 degrees. Okay, question D. It's a triangle, but one of the angles is outside of the triangle. What do we call that? Has a special name. An angle outside of a triangle. Nobody can remember? Nobody? It's called the exterior angle. And it's one of the rules that we need to know. The angle outside of the triangle is equal to the opposite angles inside added together. So the A plus the 80 is going to be equal to the 130 that's on the outside. That's what the exterior angle rule is. The two inside will be equal to the one on the opposite, the one that you don't, angle that you don't have, the exterior angle on that side. Okay? And then you will solve that by minusing the 80. So that will be A equals 50 degrees. The reason is one of the longest ones we have to write. Its exterior angle equals the sum of the opposite interior angles. A lot of abbreviations in that. Exterior angle equals sum opposite interior angles. Okay, next page, quadrilaterals. Things that have four sides, the angle sum is always 360. Excellent. So let's make an equation for this one, C. A is the pronumeral. I'm going to add on 250, add on 15, add on 70, and that will be equal to 360 degrees because angle sum of a quad equals 360. Quad short for quadrilateral. Add together the 250, the 15, and the 70. Here's my calculator. 250 plus 15 plus 70 is 335. Okay, then I do the opposite by subtracting 335. My answer is 25 degrees. I thought I'd do E as well. We don't have a rule for an exterior angle of a quadrilateral. That one we did before only works for triangles. So if you have one like this, we're probably going to have to do it in two steps. We're going to have to find that one in there first and then do a second step to get the one on the outside. Okay, so I'm going to find B. B plus the 90 plus the 97 plus the 63. So all of the angles inside the quadrilateral add to 360. That will be a angle sum of quad equals 360 again. We're going to be tight on space for this one, so I'm writing up on the top there. Then we're going to add together the 90 plus the 97 plus the 63, which gives 250. And then I will solve it by subtracting 250. And that will mean B equals 110. Not a lot of space. I haven't left as much room here. Okay, now that wasn't what we were trying to find. We were trying to find A. How can I find A when I know B? B is the key. What shape is there? What is happening between the A and the B there? They are making a straight line. So I can find A by doing A plus 110 equals 180 because straight angles equal 180. Okay, subtract off the 110 and A is equal to 70 degrees. They definitely did not make this space to show any working out, which is no good. But that is it. Hopefully you can squish that in. Question 2. Find the angle sum of these polygons, and I want to do the undecagon. So remember, triangle is 180, quadrilateral is 360. They're the ones you should have memorized. But for anything else with more sides than that, the angle sum can be found with the formula 180 bracket n minus 2. That will tell you the angle sum of any polygon. That polygon just means a shape with straight sides. So n is the number of sides that it has. So let's just quickly go through it. A pentagon has how many sides? 5. An octagon has 8. An undecagon has 11. Okay, so if I'm going to do the undecagon, I'm going to go 180 bracket 11 minus 2, close the bracket, and then just type that in. So that is 1620 degrees inside that shape. Make sure that formula, that's a good little formula. Maybe put angle sum equals that. Okay, you need that one on your formula sheet. What else do we have? Okay, question 3. Find the size of an interior angle in a regular polygon. Now, we just did the total of all of the angles. I just want one angle. Because it is a regular polygon, it means that all the angles inside are the same. So all you have to do is use the formula from the last question, 180 n minus 2. That would tell you the angle sum of the whole shape. But then you divide it by the number of sides again so that you know what one is, what one of the angles is going to be. And that will tell you, when you see that, what is each angle, that's what you'll get there. So how many sides does a hexagon have? 6. All right, let's sub it in. So we have 180, 6 minus 2 in brackets over 6. Type that in. I got 120 degrees. Okay, so nonagon has? Nope. 9 for a nonagon. Dodecagon is 12. All right, so you can do those ones by just changing the value of n. Question 4. These are kind of a big question that's often at the end of things. We would need to know the angle sum of the shape before we can work out the missing angle. So the first thing you do is you count the sides. 1, 2, 3, 4, 5, 6 sides. And you would use your formula to find out the angle sum of 6 sides. So 180 n minus 2, that's just the normal formula for angle sum. Subbing in 6, 186 minus 2. Was this the same one we did before? No, okay. All right, so 180, and then working that out, we get 720 for our angle sum. Okay, now to find A, we make a very big equation. Starting with the A, I'm going to add on all the other angles. Oh, wait, there is one more problem. Ooh, right here. It's on the outside. So what is the one on the inside? If it's 90 on the outside, it is, what was it? 360 minus 90? 270. All right, so that one in there is 270. That was a bit of an extra tricky bit for that one. So I'm going to go A plus 270 plus 40 plus 80. Oh, no, I'm missing another one. What's that one? 100. Good. Who said that? Why? Because it's co-interior. See the parallel lines? But because it is 80, that one I'm going to add to 180. So that one's 100. Ooh, I chose a good question, didn't I? All right, and then I still have to add on the 130. Equals 720. So I should have 1, 2, 3, 4, 5. No, I've missed another one. 1, 2. I should have 6 angles. 1, 2, 3, 4, 5. What have I missed? Oh, I missed the 100. I said it and I didn't write it. So I needed the 80, 100, then the 130. So that was a good little check I did. So I counted these up to make sure I had all 6 angles and I was missing one. Okay, so let's add together all of these ones. So 270 plus 40 plus 80 plus 100 plus 130 is 620. A plus 620 equals 720. So what does A equal? 100. So we minus the 620 off, and we get A is equal to 100. If the question did ask you to give a reason for that, I don't know that this one does, let me just have a look. If the question did ask you to give a reason, you would say angle sum of a hexagon equals 720. Just like we do angle sum of a triangle equals 180. Angle sum of a quadrilateral equals 360. So this would be angle sum of a hexagon equals 720. I think that might be the end. Yes, it is.